Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy, and I am Jeetendra Dixit. Here's my profile. So I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years. I teach mathematics and today we will discuss trigonometric functions, inverse trigonometric functions, okay? So we'll start inverse trigonometric functions, we'll see the domain, range and graphs of inverse trigonometric functions, and then in upcoming lectures we'll continue that, okay? Let me check my voice. Yeah. All right. So before we start, let me tell you about the Unacademy subscription. So as you know, Unacademy is India's largest online learning platform. And once you get the subscription for IIT-JEE, you have two types of subscriptions you can buy. One is Plus, another is Iconic subscription. So let me tell you about both the subscriptions in detail. So Plus subscription, in Plus, if you're preparing for IIT-JEE and you take Plus subscription, then you get access to daily live classes of all the educators. Okay, you can access any educator who is teaching on an Unacademy's platform. So you know India's top educators are teaching there, so you can access anyone's class there. And apart from that, you can also access live tests and quizzes. Live tests and quizzes will also be applicable, and even if you miss something, you can watch recorded lectures. All the lectures are recorded. You can watch them offline by downloading them, right? So that option is there. Yeah. Now, this is the unlimited access you are getting on the platform once you have the Plus subscription. Now, these are the subscription charges. You can subscribe for 1, 3, 6, 12, and 24 months. All right. So 12 and 24 months, let me tell you, is 38,500 because these are economically the best packages, and 24 months is 56,000 for 2 years, right? And you'll get 10% discount in this. So finally, you have to pay 34,500, 650, and 50,400. Easy, no cost EMI available are also available for 6 and above subscription, 6 months and above. All right. Now, second is Iconic subscription. So as you know, in Iconic subscription, you get all the benefits of Plus, and apart from that, you get a personal coach. You get a personal coach. Your test analysis will be done in a personalized manner. Your personal coach, that means an expert, will guide you throughout your preparation for IIT-JEE. Your test analysis will be done in a personalized manner. Your personalized feedback will be given to you to improve your time management and exam approach. Your study planner will be customized. So all these benefits you'll get apart from all the benefits of Plus, all right, in Iconic subscription. So these are subscription charges. For 1 year it is 56,000, for 2 years it is 86,000, and you get 10% discount. So finally you have to pay 50,000 and 77,400. I hope it is clear. Now you can see this is Unacademy's learning app, which you can download from Play Store. And one more thing, one very important point: even if you even if you don't have any subscription or you are not planning to buy it now, then also you can avail unlimited special classes. I mean, you can attend unlimited special classes on the platform. Just make your account and start learning. Every day, top educators are taking special classes on various topics on Unacademy's platform. So you just go and watch them live, okay, on this app. So you can interact with your educator during the live session. So these classes are exactly the same which you get after Plus subscription. So platform is same, everything is same. You can chat with your educator. You can participate in poll. So there are many features you will get to know. So just attend special classes if you don't have any subscription, and you'll learn a lot. Now let's begin today's session. All right. So inverse trigonometric functions. So inverse, when is the inverse of a function is defined? Inverse of a function is defined when it is 1, 1 and onto. Inverse of a function is defined when function f is when f is 1, 1 and onto, right? But no trigonometric function is 1, 1. So how to make any trigonometric function 1, 1? Let's talk about sine x. So if you see y is equal to sine x, we know that graph of sine x is like this. It is many one function because they are periodic functions, and periodic functions repeat their values. So because they are repeating their values, so of course there will be many one. Okay, 1, 1 means you will get one value of y only once. Okay, so you can see in this function sin x, if I pick a part of sin x which is only increasing or only decreasing in the domain I have picked. Okay, so as you can see, if I this is 0. Okay, this is 0. So around 0 we get one interval in which this function is 1, 1, and that interval is pi minus pi by 2 to pi by 2. So if I take this interval x belonging to minus pi by 2 to pi by 2, sin x is always increasing. Okay, that means you'll get one value of y only once. It won't repeat. Y won't repeat its values. You won't get two values of same value of y for two different x if function is either increasing or decreasing for the entire interval. So if I restrict the domain of sin x, then I can make it 1, 1. Similarly, onto. Function is onto when range is equal to codomain. So in the domain which I have picked for this function to be 1, 1, which is minus pi by 2 to pi by 2, in this domain, range of the function will be minus 1 to 1. So if I take codomain minus 1 to 1, then this function is going to be 1, 1 and onto, and then we can define the inverse. So here is the way to define the inverse. First of all, I define the function f from minus pi by 2 to pi by 2. Okay, this interval, and from this interval to what is the codomain? Codomain should be equal to range. So because I know that range is minus 1 to 1, so my codomain should also be from minus 1 to 1. So I've defined function like this. Now I can say that sin x, what is the function? Fx function is sin x function. Okay, sin x. So now this function is 1, 1 and onto, and its domain is minus pi by 2 to plus pi by 2, and range you can say is minus 1 to 1 because range is equal to codomain in onto function. So this is now invertible. That means now you can define the inverse. So we define the inverse of sine as now say f inverse. So f inverse of x is equal to sine inverse. We write like this. Okay, notation we know of inverse. So f inverse x is sine inverse x. Now what will be the domain of this function and range of this function? So domain will be the range of sine, and range will be domain of sine. Okay, domain and range interchanges. That's what is the inverse function. Inverse function will be from this was from a to b. Now inverse function will be from b to a. So b will become domain and a will become range. This is for f inverse, right? So domain is nothing but minus 1 to 1, domain of sine inverse. Okay, and range of sine inverse, range of sine inverse will be minus pi by 2 to pi by 2. So this is what the range and domain of sine inverse function. Now we need to look at the graph. So do you remember that the graph of when we did inverse function, then you must have studied one thing, that graph of f and graph of f inverse are images of each other about images of each other about y is equal to x line, right? Y is equal to x line. So if I, 1 minute. So if I try to plot the graph of f, any sine inverse, that I can do using the graph of sine x, okay? So because I know this is y is equal to x line, this is y is equal to x line, okay? I know the graph of sine is this. It is above x, y is equal to x line when x is negative, and below y is equal to x line when x is positive. We have already done this thing in limits and in graphs. So this is the graph of sine x, okay? This is the graph of sine x in the interval which we have defined. Now the inverse, sine inverse, I have told you this graph in limits also. Sine inverse is the image of graph of sine. So sine inverse will be like this. Just take the reflection of this green graph about this y is equal to x line, y is equal to x line, okay? So exactly the mirror image like this. Okay, so now this point is going to be -1 and this point is going to be +1. Domain of this yellow graph. Yellow graph means and this point is going to be pi by 2 range and minus pi by 2. Okay, so this is minus pi by 2. So graph of this sine inverse lies inside this box. What is this box? This box is -1 to 1 horizontally and minus pi by 2 to plus pi by 2 vertically. Okay, this this is the graph of sine inverse x. Okay, if I ask you one question, find the number of solutions. Find the number of solutions of sine inverse of x is equal to sine x. Then can you tell me number of solutions? And also we can tell the solution, right? So you can see these yellow and green graphs. Green graph, although you can, because we are writing sine x, this question is independent of this theory. Okay, so here sine x, here sine inverse x is defined from -1 to 1, so obviously solution will come from -1 to 1 only. After that sine x, there's no use of sine x. So in -1 to 1, if we see, so sine inverse x and sine x meet only at one point, and that point is origin. Okay, so yes, solution of this is one solution. The solution of this is, I mean, x is equal to 0, and there's only one solution. All right. So now let's do the cos inverse. Okay, this was the first function, and similarly we'll define cos also. So in this manner we can define all 6 inverse trigonometric functions. So second is fx is equal to cos x. Okay, here now again, by looking at the graph of cos, you need to figure out, okay, an interval around 0, okay, around 0, where this cos function is invertible, I mean 1 1. Okay, so just have a look and decide an interval in which this is 1 1 mainly. Okay, because 1 1 is important point, and codomain you can adjust by setting the codomain is equal to range. So now here in this graph you need to look for a part around 0, which is 1 1. So if I see this part after 0, so either we take minus pi by 2 to pi by 2 or 0 to pi. Okay, in these two intervals, all 6 trigonometric functions will give you 1 1 function. I mean, they will be 1 1 either in 0 to pi or in minus pi by 2 to pi by 2. So basically these are the intervals which we need to pick. So 0 to pi, these are standard, for standard trigonometric functions they have taken intervals like this. So this is once defined and it will be right like that. Obviously you can take the inverse of cos in minus pi by 2 to 0 also, that is also invertible, but that we can define in terms of the standard inverse which we are defining. Like we have defined sine inverse, okay? We have defined sine inverse of this part, okay? Sine inverse of this part, and that is given by this sine inverse x, right? Now, if somebody asks you the inverse of this part, which is pi by 2 to 3 pi by 2, yes? Yes, you can find that inverse also, but that will be sine inverse x plus something or minus something, okay? Sine inverse of x plus something. That means inverse of this we can also define, but that will be in terms of the standard sine inverse which we have defined in the interval minus pi by 2 to pi by 2. Okay, so in terms of that we can define the inverse of all the parts of sine x. You pick any interval, okay? We'll do that later. First, let's continue and finish this cos x part. Okay, so in 0 to pi, you can see this function is decreasing, okay? The function is increasing, its inverse will also increase. One important point, I'm just mentioning it here. And when inverse is decreasing, its inverse will always decrease, okay? So this is the cos inverse. So I have defined the function from 0 to pi and 0 to pi to minus 1 to 1, okay? Minus 1 to 1. So is in this interval, you can see fx is equal to cos x is invertible, okay? This is invertible. Then we can define f inverse x is equal to cos inverse, okay? So this is defined as cos inverse x. Now what is the domain? Let me write the domain, okay? So we write inverse of cos as cos inverse x. Now this domain of cos inverse will be the range. Here you can see minus 1 to 1. So whatever was the range of sine and cos, that is going to be the domain, and that will happen in other functions also. Like in tan, range, you know, is all real numbers, so that is going to become the domain. But range will be different. Range will be that domain of cos where we have defined the inverse. So that domain was 0 to pi. So range in all trigonometric function will be either minus pi by 2 to pi by 2 or 0 to pi, because as I told you, we are going to define these functions, inverse of these functions, only in these two domains, either in 0 to pi or in minus pi by 2 to pi by 2. So range of all 6 inverse trigonometric functions is going to be either 0 to pi or minus pi by 2 to pi by 2. So if I further tell you about this, then 3 functions will have range from minus pi by 2 to pi 2, and 3 functions will have range in 0 to pi, 3 inverse trigonometric functions. Yes, but that might happen that 0 to pi closed, in some other function it might be 0 to pi open, or a few points might change, but uh, in general you can say that the large interval is going to be 0 to pi. Maximum points are going to fall in that interval, except a few points, 2 or 3, 2 or 1 basically. Alright, so this is cos x. Now we need to draw the graph of this function. So let's see how to draw the graph of cos. Okay, so first I'll make the graph of cos. The graph of cos is like this. This is 1 and this is pi by 2, okay? Pi by 2 comma 0. Now this is y is equal to x line. Now let's draw. Let me make this graph green. This part we are going to take the image of this part. So that part is going to be like this. Graph of fx and f inverse x meet each other at y is equal to x line. So this point is -1 and this point is +1. So that is going to be the graph of cos inverse. And this range, is 0 to pi. So this point is going to be pi and this point. So graph of cos inverse will lie in this box. The box whose domain is -1 to 1 and range is 0 to pi. Okay, in this box. And this cos inverse and cos will intersect each other at y is equal to x line, but we don't know this point. What is this point? We don't know. No? But certainly it is less than 1. So cos inverse of x is equal to cos x again has one solution. Okay, one solution. Is that okay? Yeah, is that okay? These two equations have one solution. So I hope it is clear. And you can, as you know, cos x is decreasing in 0 to pi. So cos inverse x will also be decreasing, and you can see that in the graph. Cos inverse x is a decreasing function. So sine inverse was increasing, cos inverse x is decreasing. Both have same domain but different ranges. Okay, minus range of sine inverse was -π/2 to pi/2. Range of cos inverse x is 0 to pi. So to understand trigonometric functions, it is very important to understand the graphs of these functions, basic trigonometric functions, elementary, and their range and domain. Very, very important. Okay, very, very important. And it's very good if you remember the graphs also, apart from range and domain. Okay, now third is fx is equal to tan x. Now see, let's have a look at the graph of tan x. Okay, then we will so graph of tan is like this. So now you can see in -π/2 to pi/2, tan x is always increasing. After that, it is going to repeat its values. So it won't remain many one, right? After that, it is again going to be same. So you can see we are going to take this part, which lies between -π/2 to pi/2. So this part is going to be 1, 1. But one important point to notice in this is that -π/2 to -π/2 and pi/2 will not be included in the domain. So when we define this function f, we'll take the domain from -π/2 to pi/2. See, it is very similar to domain of sine, but endpoints in this case are not included because tan is not defined at -π/2 and pi/2. So these 2 points are different. Otherwise, domain is same as the domain of tan sine. I mean, sine was invertible in this interval, and tan is also, leaving the endpoint. So I hope it is clear. I told you that there will be three functions will have domain in -π/2 to pi/2. And range you can see is R. So range of tan is R. So you can take codomain also equal to R. Now your f function is tan x. Now let's define f inverse. So now you can define f inverse x is equal to tan inverse x. All right, f inverse x is equal to tan inverse x. And once we plot this, fx is equal to tan inverse x, then now we can write domain and range of this. So domain is going to be R, which was range here, and range is going to be domain of tan, which is -π/2 to pi/2. All right, this one. So I hope it is clear. Now let's focus on the graph. So I'll take the help of this already drawn graph. I'll remove this part. Okay, and let's take the inverse of this part. Okay, now I need to take the support of y is equal to x line. So as I know that y is equal to x line is below tan x. Okay, this is y is equal to x line, and above tan x according as x is positive or negative respectively. All right, so this is y is equal to x line. Now you need to take the image. So when you take the image of this graph tan x, okay, then image is going to look like this. This is going to look like this. Okay, this, and so this is tan inverse x, because tan x was touching this vertical line, so tan inverse will touch this horizontal line. And what is this horizontal line? If you see, this vertical line was x is equal to pi by 2, so this vertical line is going to be y is equal to pi by 2. And we can also observe from the range of tan inverse. That range of tan inverse is given from minus pi by 2 to pi by 2 open. The tan inverse is this function which is always increasing, but it is always bounded function. Bounded, bounded means its range is between c to d, where c and d are finite numbers. Okay, that is called bounded function. So this is the range. All right. So I hope it is clear. Huh? You've got the graph of tan inverse. Huh? Now let me ask you this question, and be careful answering before answering this. Number of solutions. This question is independent of the theory I have told you. Okay. So do not follow these domain and range. Okay. Now it's a general question. Number of solutions of tan inverse x is equal to tan x. Okay. Now just do not look at this. I mean domain and range. You can take anything you want. So you need to find the number of solutions of this. Try this one. I'm not saying x lies in this or that. You can define your x for this question. All right, now let me answer it. So as you know, tan inverse is like this. Tan x is like this. This is tan x. Domain of this is r, right? X belongs to r. And domain of this function is x belongs to r minus odd multiples of pi by 2. So common domain is this, right? X. So this will be the domain. So that means you can draw tan x, full graph of tan x, okay? Like this. Like this. If you draw the tan inverse, then clearly, even if you draw only this part, you can see that tan inverse is going to be like this, okay? So it is going to meet all these parts, okay, for some x, for this point, and it will keep cutting this graph. Because tan x repeats infinite times. Tan x repeats infinite times. Periodic function. So this tan inverse will keep meeting these parts, okay, and you'll get infinite number of solutions. You'll get solution in negative side also, because both functions are odd functions. Yeah, tan inverse x is an odd function, okay? This is an odd function, And I'm sorry, I forgot to mention about sine inverse also. Sine inverse x is also an odd function, and odd functions means sine inverse of minus x is equal to minus of sine inverse of x. Okay, this thing. But cos inverse is not an odd function. Okay, this has a different relation. Cos inverse of minus x is not minus cos inverse x. It has a different relation. I'll tell you that relation later. But tan inverse of minus x, tan inverse of minus x can be written as minus tan inverse x. Okay, this can be written as this. So tan inverse x is an odd function. So symmetrically, it will cut at the negative side of x-axis also for infinite number of times. So total solutions, you can say total solutions infinite. Okay, same number of positive and negative solution. If you're getting x as a solution, then minus x will also be a solution. So if he frames question like this, find the sum of solutions of tan inverse x is equal to tan x in the interval minus 10 pi to plus 10 pi. Minus 10 pi to plus 10 pi. So if you count them, then up to pi you see there's only one solution. Up to pi there's no positive solution. 2 pi there's one solution. 3 pi there's two solutions. So up to 10 pi there will be 9 positive solutions, and from minus 10 pi to 0 there will be 9 negative solutions, and one solution is 0 only. When you add all these solutions, then all positive solutions will cancel out all negative solutions. So total solutions, by the way, are 19. But if you add all the solutions, then some of the solutions is going to be 0 only. Okay, in this interval, minus 10 pi to plus 10 pi. So I hope you understood this. I'm just framing a question on taking the property of odd functions. I mean, because this function is an odd function. All right. Now I'll tell you about the chord function, okay? Chord inverse. So first of all, let's have a look on chord functions, graph of chord function. So this is the graph of chord function, okay? Rough sketch, let us plot. This is the graph of chord. This is the graph of chord, okay? This is x, y axis, and this is x. So 0 to pi, if you take interval, then chord is going to be decreasing, okay? So we have got our interval because we need to decide either 0 to pi or minus pi by 2 to 0, okay? It's pretty simple. So if I define fourth function, if I define my function from 0 to pi, but now you can compare it with cos. Cos was also defined from 0 to pi, but this cot endpoints of this interval are not included because cot is not defined at 0 and pi. So those 2 points are excluded, and apart from that, range is going to be R only. So range is equal to codomain. Now you can take fx is equal to cot x, which is in cot x, which is invertible. Now it is 1, 1 and on 2. So now you can define f inverse, and as you define f inverse of x, we write as cot inverse of x. All right, cot inverse of x. Now what is the domain of cot inverse x? So domain of this is going to be, domain of cot inverse is going to be R, all real numbers, and range is going to be 0 to pi. So I hope it is clear, huh? Now let's plot this cot inverse, graph of cot inverse, huh? Okay, so if I plot the graph of cot inverse, so first let me plot the graph of cot, whose inverse we are going to plot. So this is the graph of, so we'll cut the x-axis at pi by 2, and it will go down vertically. It will become vertical almost. Touch this line, x is equal to pi, right? Now this is y is equal to x line. Y is equal to, so this is y is equal to x line. We need to take the reflection of cot about this line, okay? So first of all, you should plot, because this graph cot is between x is equal to 0 and x is equal to pi line. So graph of cot inverse will be y is equal to 0, which is x axis, and y is equal to pi line. So if you plot y is equal to pi line, it is going to be like this. So graph is going to be between these two lines. All right. Now it is a decreasing function, so cot inverse will also be decreasing. Cot inverse will also be decreasing. Okay. So far it is good. Cot inverse is a decreasing function. Now you can see when x is approaching to 0 plus cot inverse is infinity. So that means when cot inverse, cot x is infinity, I'm sorry. So when cot in inverse function, when cot inverse of infinity you will check, then it will be 0, the inverse of this. And this point is, you can say 0 plus comma infinity. So in cot inverse it will be infinity comma infinity. It is going to be close to 0. And at minus infinity, by the same logic, it is going to be close to pi. Graph will start from this. Pi. It will come like this, decreasing. It will cut the y-axis, okay? And it will meet the graph of cot at this point, where cot was meeting y is equal to x line. And then it will keep going like this. So this is the graph of cot inverse x, okay? It's a decreasing function. Is it odd? No, this is not an odd function, okay? Only sine inverse and tan inverse was odd. Cot inverse, like cos inverse, it is not an odd function. It is decreasing function, that we can say cot inverse x is a decreasing function, okay? And domain we know, range we know, graph we know, right? And if I ask you number of solutions of cot inverse x is equal to cot x, then how many solutions this equation will have? Then again you can say infinite solutions, because the domain of this function cot is r minus n pi, domain of cot inverse is r. So common domain of this equation is going to be r minus n pi. So you will draw cot inverse further also, cot x. And this cot x, graphs of cot x will keep cutting this cot inverse, right? But this time positive and negative solutions will not be symmetric, okay? That's an important point. So they will have infinite number of solutions. This equation has infinite solutions. All right, so two more graphs are remaining. Now, the fifth one is graph of fx is equal to, let's say, cosec inverse x, okay, cosec x. So f we have to define. Let's see cosec inverse graph of cosec x. So if you see the graph of cosec x in minus pi by 2 to pi by 2, it is like this, decreasing. Then it will go up, so I'm leaving that part. It will take up to pi by 2. And if you see minus pi by 2 to pi by 2, then it is like this, decreasing, okay, completely. This point is minus pi by 2. So if you define f function from minus pi by 2 to pi by 2, see again you have got that interval, but in this case 0 is excluded. 0 is not there in the domain, okay? So you are getting all the points except 0 in the interval line. This is the interval where cosec inverse we can define, and range is going to be minus infinity to minus 1, range of cosec only, union 1 to infinity, full range, okay? So interval we have chosen so far. In those intervals, all the trigonometric functions were giving us their complete range. This is the complete range of cosec, okay? Now, when we have taken f, defined f in this interval, then now you can see f inverse of x is, we will define as, now f first let's define f. Now this is your f function, f is cosec x, okay? This is your cosec function. Now it is invertible, and after it is invertible, we can draw f inverse x is equal to cosec inverse of x, and you can see cosec inverse of x, in cosec inverse of x, domain is going to be minus infinity to minus 1, union 1 to infinity, and range is going to be minus pi by 2 to pi by 2 except 0. Okay, all the points. So if I plot the graph y is equal to x line, then y is equal to x line is going to be like this. It will cut cosec 2 points. That means cosec inverse is also going to cut. Now if I plot cosec inverse, then cosec inverse will start from this point. Okay, this is 1 comma pi by 2, and it will be like this. If you take the image, then it is going to be like this. It will touch x-axis at infinity, like cosec is touching y-axis at infinity. And now here it will start from this point, minus 1 comma pi by 2, minus pi by 2, and it will go like this. Alright, this is minus pi by 2. This point is plus pi by 2. Alright, so now this is the graph. Okay, this is cosec inverse x. Got it? There's another way, another interesting way to remember the graph of cosec inverse. I'll tell you that interesting way. See, do you know that cosec is inverse of sine? When you draw cosec, the graph of cosec x, then you just invert the graph of sine like this. Okay, along, vertically you invert it. The point which is going to 0, close to, which is touching x-axis, that goes to infinity. So in case of cosec inverse also you can do the same. Like we know the graph of this is the graph of sine inverse, which is easy to remember for most of us, but generally we forget the graph of cosec inverse, because once I'll tell you the graph of sec inverse, then you will come to know. Now if you take the inverse of this horizontally, like you take the inverse of sine vertically, so it is going to be like this. The point which is going, this graph is going close to y-axis, so inverse of this horizontally will go to infinity. The point which is going close to y-axis, inverse of that is going to plus infinity. Okay, like this. And then take the inverse of this graph, negative values. So in this way you can remember this. This green part is graph of cosec inverse x. They meet each other at 1 comma pi by 2 and minus 1 comma. This is a common point. These 2 points are common points in sine inverse x and cosec inverse x. So if they ask you the solutions of this sine inverse x is equal to cosec inverse of x, then solutions are x is equal to plus minus of 1, minus 1 and plus 1. One thing. Second, if they ask you the solutions of cosec inverse x is equal to cosec x, then how many solutions? Even if you draw cosec further, then it won't meet cosec inverse. So they will have only 2 solutions, which you can see in the graph. 2 solutions. Are you understanding this? Third, cosec inverse, can you see it is symmetric about y-axis, origin. So cosec inverse x is an odd function. So see how many points I'm telling you. Odd function, that means cosec inverse of minus x is equal to minus of cosec inverse of x, right? So many points. So you can see we can form a lot of questions based on this information, just based on this graph, domain, range, and graph, right? So much of, this information is very, very important information. Now we are left with one more. So the last is sec x. So let's plot the sec graph of sec. So let's plot the graph of sec x quickly. This is the part. This part I'm leaving because it will repeat the values. And then further if you go, this is up to pi by 2. And further you go, then it will be like this, okay? This is up to pi. So in 0 to pi, you can see this part is invertible, this part as well as this part, because this is not repeating the value. So in this, you take f from 0 to pi, but which point is excluded? One point is excluded, and that point is pi by 2. So you need to exclude that point. From this domain to range is going to be minus infinity to minus 1 and union 1 to infinity. I'll take AOD Raghav after this. I'm just about to finish it, and after that I'll start AOD in next session. But I'll take a break of 10 minutes and then we'll start AOD. Okay. Straight line course, you mean what? That pair of straight lines I'm going to take today. Are you talking about pair of straight lines? Alright, so f function is defined from fx is now defined as sec x function, okay, in this interval, which is invertible because 1, 1 and 1, 2. Then we define f inverse x is equal to sec inverse x, whose domain is minus infinity to minus 1, union 1 to infinity, and range is 0 to pi except pi by 2. Okay. In that I will cover theory only, theory of pair of straight lines. I'll try to finish the theory in one session. That's like a special class because Sunday is a YouTube day, so I plan 2-3 sessions. So I have taken that topic. Inverse trigonometric functions I might continue in other sessions. I mean, because this has interesting graphs and some interesting points. Okay, so now let's plot y is equal to x line. First of all, we know the graph of sec. This is the graph of sec function, and this part, this is one vertical line. Now we need to plot one horizontal line as well, and that horizontal line is going to be pi by 2, this line. X is equal to pi by 2. So if you take the inverse of this part, then inverse of this part is going to be start from here, will be like this, and will meet this line, which is okay. And second part, this point is pi comma minus 1, so minus 1 comma pi will be here, and this second part is going to be like this. Okay, so this is the graph of all right. This is the graph of sec inverse. Now I'll tell you one shortcut to draw it. Do you know the graph of, we know the graph of cos inverse x, right? So first we'll plot that graph of cos inverse, okay? And like we have taken the inverse of sine horizontally, okay, we'll draw this line horizontal, okay, and now we can make the graph of cosec inverse. So the point which is going to 0, just take you're taking the reciprocals, it will become infinity horizontally. So it will go like this, and similarly this part will go like this. So you can understand it with the graph of, this is cos inverse x, and this blue graph is sec inverse x. All right, this is sec inverse x. In this way you can remember it. Okay. sec inverse. This is not invertible. This is not odd function. So three most trigonometric functions are odd functions. Now I'm summarizing domain, range, and properties of these functions. So domain of sine inverse, cos inverse is same, -1 to 1, -1 to 1. Domain of tan inverse and cot inverse same, r. On domain of cosec inverse and sec inverse same, -infinity to -1 and 1 to infinity. All right, and then their range. So three functions lie in 0 to pi. Which three functions? Cos inverse, cot inverse, and sec inverse. But in cot inverse, 0 and pi are excluded, and in sec inverse, pi by 2 is excluded. Okay, in cos, all the points up to 0 to pi, from 0 to pi, including 0 and pi, will be in the range. And in three functions, which is sine inverse, cosec inverse, and tan inverse, range will be minus pi by 2 to pi by 2. But in tan inverse, minus pi by 2 and pi by 2 will not be included. And in cosec inverse, pi by 2, 0 will not be included. Okay, so this is all about the range and domain. And three functions out of the six trigonometric functions, three functions, tan inverse, sine inverse, and cosec inverse, are odd functions. Okay, so if you put minus x, then minus will come out. All right, so these were the graphs, domain, and range of these functions. Now I'll take continue after this. Okay, so this was about this session.